Alright, so this is going to be a video where it's basically a breakdown of a slope fields example problem, and it's multifaceted, so hopefully it will help you get an understanding of slope fields and the type of problems that you should be able to figure out and solve. So it says right here, consider the differential equation given by this dy over dx right here. So it is important to contextualize this and just think of it as this equation basically tells you the slope of any point. As long as you know the x and the y and you multiply the x and the y and divide by 2, it tells you the slope at every point. So it says sketch a slope field for the given differential equation on the axis provided. And then it has a bunch of dots, and then you're basically going to be creating a slope field using each of these dots here. The easiest one to pick first probably be the origin. It doesn't look like there's a dot there, but let's just assume there is. And at the origin, the x is 0 and the y is 0. So it would just be 0 times 0 divided by 2 is just 0. So I'm going to make a slope field of 0 there. Okay, now anywhere where there's an x is equal to 0, it's going to be 0 times something divided by 2. 0 times anything is going to be 0. So I'm actually going to put a horizontal line everywhere where x is 0. So those are all the slopes at those points there. I'm going to zoom in a little bit. Okay, now what I'm going to do is do all the points where the y is equal to 0. Okay, because if y is 0 in this equation up here, then the slope is still going to be 0 as well. So this will be 0. This will have a slope of 0. This will have a slope of 0. This will have a slope of 0, and this will have a slope of 0. Okay, now I'm going to pick another easy point. Probably 1, 1 is a good point to do, 1, 1, where x is 1 and y is 1, because then it would just be 1 times 1 divided by 2, which is 1/2. So at this point right here, 1, 1, it's going to be 1/2. So that means it should basically be going from here to this point right here. So I'm going to kind of just make my line based off that like that. So that's my 1/2. And you can kind of see if I, kind of went through with this a little bit further, you can see that it's up 1/2 over 1. So kind of use other parts of this. So here, let me just show you. I'll zoom in here. So if you actually work this out, it goes to about 1/2. So it's up 1/2 over 1. So the slope would be 1/2 on that. So you just kind of sketch it off of that little part right there. Then I'm going to do 1, 2. So it'd be 1 times 2 divided by 2, which is going to be 1. So for 1, I'm just going to base it off this right here to 1 and end up with something like that. Okay, again, if you want, you can make a little dashed line and you're going up 1 over 1. So then it's a slope of 1 at that point. Maybe erase those dashed marks though too. You don't want to lose any points on an AP test or some other test your teacher might be giving you. The main thing is this green right here. Okay, let's do this point right here, which is going to be 2, 1. That's also going to be 1 because it's 2 times 1 divided by 2. So we're going off this point right here. So it'd be something like that. Let's see. That's pretty good with that one. All right, now if we did 2, 2, right up here, it'd be 2. So that means you should be going based on this one right here. It's going to be a little bit steeper. And again, you can kind of do the dashed lines. You can see that it goes up. It's going up 2 over 1 for that. I'm going to get rid of these though because I don't like looking at them. Let's keep going over here. All right, so this would be 3 over 2 here for this one. So we basically want to go up 1.5 and over 1. So here's the over 1 here, but 1.5 would be like maybe right here because it'd be 0.5 plus 1 and then over. So I'm going to kind of sketch that, just maybe make it a little bit easier for you. End up with something like that, up 1.5 over 1, kind of a rough sketch. So then the final answer would be based off this point right here, and then just angle it like that. That looks kind of like 1. Let's do this. So it should be a little bit steeper than this 1 right here. Okay, then this one's 3, 2 up here. So this should have a slope of 3. 1, 2, 3, and then over 1. So we're basing it off of this point right here. So this should be pretty steep here, and it's going to be steeper than our 2. So this is our 2, so this should be a little bit steeper. I don't really like the way that's drawn, so let's do it a little bit better. Something like that maybe. Okay, this one right here, 1, -1, that should be -1/2 then because it's 1 times -1 divided by 2, so that's -1/2. So let's draw that in here, -1/2. So we're going to have a negative slope now, basing it off this right here, so it would be something like this. Okay, this one, 2, -1, that's -1, so we're basing it off this right here. Let's do that. Let's draw that one a little bit better, probably something like that, maybe that's a -1. And then this is going to be 3 comma negative 1. So that's going to be negative 3 halves. So 1, 2, 3 over 2. So it's going to really be going up 1.5 to like right here maybe. So something like that. Okay, moving on. Let's do this one right here. It's going to be negative 1 comma 1. So that's negative 1 half. So negative 1 half would be to go right here maybe. So it's that. Okay, negative 1, 2 is going to be negative 1 for the slope. So it'll look something like this. Negative 2, 1 is going to be negative 1 for the slope. So it's going to be something like negative 2, 2 is going to have a negative 2 slope. So it'd be down 2. So it's based off this one right here. Something like that. Negative 1, this one right here would be 1 half because it's negative 1 times negative 1 divided by 2. 1 half like that. And then this one's going to be negative 2, negative 1, which is going to be 2 over 2, which is 1. So it's going to be like something like that. Now it is important to check your work on this to make sure it does look all right, making sure one's not steeper than the other, especially if it's supposed to have higher slope. But it should look something like that. All right, so that's basically part A. For part B, it says let f be the function that satisfies the given differential equation. Write an equation of a tangent line of the curve y equals f of x through the point 1, 1. So I'm going to write that down here. So this is part B. So basically we're figuring out the equation of a tangent line. So we want the y equals mx plus b for a point that's going through 1 comma 1 and has that differential equation, the given differential equation right here. Okay. Well, what's good about this differential equation, it tells us the slope of any point, including the slope at 1 comma 1, which says right here is what we're looking for. So we're looking for the slope through 1 comma 1. So we know at least the slope at 1 comma 1. We know that the slope at 1 comma 1 is going to be equal to 1 times 1 divided by 2. So the slope is going to be 1 half. So we have the slope for our equation. It's going to be y equals 1 half x plus b. We just need to figure out this b, and then we have the entire equation. Well, luckily we have the coordinate right here. It's just 1 comma 1, so we can put 1 in for y and then 1 in for x here plus b, and then you could solve for b here, and b is going to be equal to 1 half because 1 half plus 1 half is going to be equal to 1. So then you end up with the final answer for the equation of a tangent line to be equal to 1 half x plus 1 half. That's not the only thing that's asking for in this problem. It's also asking for, it says here, then use the tangent line equation to estimate the value of f of 1.2. So basically now our x is 1.2. They want us to use this equation right here to figure out what f of 1.2 is. So what I'm basically going to be doing to figure out what f of 1.2 is, the approximation anyway, so f of 1.2 is going to be approximately equal to 1 half of 1.2. So 1 half times 1.2 plus 1 half. This whole thing right here ends up being 0.6. So it's 0.6 plus 0.5. So the answer should be 1.1 for this approximation. So we're using this y equals mx plus b to figure out that approximation. All right, so for part C, it says it's a calculator problem. So it says find the particular solution of y equals f of x to the differential equation. So now we're actually solving that differential equation, and we're using this initial condition right here. It says f of 1 equals 1, and it says use your solution to find f of 1.2. Round your answer to 3 decimal places. Okay, so now we're actually going to find the exact value of f of 1.2. If you notice for part B, we found that 1.1, that was an approximation. So now we're going to actually find the exact number for this. And to do that, we have to solve the differential equation that was given. So this is kind of a review from the previous unit. So it says the derivative is equal to x times y over 2. All right, now we're going to solve this by separating the variables. So I'm going to divide both sides by y to get this. And then you're going to end up with 1 half x still on this side times dx. So I multiply the dx over. From here, I'm going to do the antiderivative of both sides, so I'm the integral of both sides, and you end up with ln y on this side is equal to, now it's going to be x squared over 2 times 1/2, so it's going to be x squared over 4 plus c. Now from here, I'm going to solve for my plus c by plugging in that 1 comma 1, because it said f of 1 is equal to 1. So if you plug in 1 for y here, you're going to end up with ln of 1, which is 0, is equal to 1/4 plus c, and you end up with your c being equal to negative 1/4. So now that you know the c, your equation, your solution to the differential equation is going to be ln of y equals x squared over 4 minus 1/4. If you base e both sides, you're going to end up with a solution of y is equal to e to the x squared minus 1 all over 4, because I just combined the common denominators here to get this. So this is actually the solution to the differential equation. It says to use this solution to figure out what f of 1.2 is. So we're trying to figure out what's f of 1.2. Okay, well f is the y in this case, and 1.2 is the x. So I'm basically going to just be putting 1.2 into the x of this equation right here and solving. And this is where it says to use your calculator, because you end up with some crazy decimal number. So you're going to end up with e to the 1.2 squared minus 1 all over 4. Now it says to round this to 3 decimal places. So I'm going to put this in my calculator real quick, and you should end up with 1.116 for the 3 decimal approximation. Here's the exact, this part right here, but it says to round your answer, so that's why I'm doing this. So you end up with something like that. Okay, for part C. For part D, it says compare your estimate of f of 1.2 found in part B to the actual that's found in part B. All right, so clearly this is a typo. This is supposed to say found in part C. I just made a typo there. Okay, so it's comparing what you got in part B with what you got in part C. So if you notice, for part B, I got 1.1. For part C, I got 1.116. So for part D, it says compare your estimate. So you would say that, I would just say the estimate was close, I guess. The estimate was relatively close. Okay, and then part E, it says, was your estimate from part B an underestimate or overestimate compared to part C? Use your slope field to explain why. All right, so for part E, you should be able to see that what you got in part B, the approximation, was a little bit less than the actual. So you would say that it was an underestimate. And then it says, use your slope field to explain why. So if we go back to the slope field right here, this should help us explain why it's an over or underestimate. So let's see here. Let's do, what I'm basically going to be doing here is sketching what's going through this point 1, comma 1. So if you made a slope field based on this, so it looks something like this, I guess. Now, based on this, you can see that if we zoomed in here, you would see that the tangent line from this, here, let's draw that with a different color here. Let's do this. The tangent line that we came up with would be right here. And the purple would be the exact right here. So if you were actually doing f of 1.2, let's just say f of 1.2 is considered right here. If you notice the approximation, this bottom part right here, is going to be an underestimate. So it's because this is concave up that this part, the actual value, which is this part right here, is greater than the estimate, which is right here. Okay, because again, the estimate is based on that equation of a tangent line, which is right here. But since this is concave up, the actual is up here, the estimate is down here. So that's why it's an underestimate. So for your explanation, I would probably write it's an underestimate, and the reason why is I would write because y is concave up. So because it's concave up, it's going to be an underestimate compared to the actual. So that's basically how to do a pretty involved example problem using slope fields. If you have any questions on anything in this video, let me know.